I'm leaving at lunch on the 26th, and then we'll be back until maybe the 30th.
Okay. All right, guys. I'm videoing now. So this is all going to go online. How awesome is this? Okay. Shh, Tanner. Okay, so just a reminder, October 13th, that is your unit exam. Okay, so that's Thursday. Thursday's your unit exam on all this trig stuff. Now I have a nice quiz for us today that's going to highlight all the important aspects. Well, the second half of them anyways, that you need to know. Thanks, Stevie.
Wait, isn't the exam tomorrow?
No, Thursday.
So tomorrow's our review day?
Yes. Okay, so you basically have 2 review days. It's quite nice. Now, if we look here, it says the conditions for the ambiguous case of the sine law. So sine law, the ambiguous case, is what we looked at on Thursday last week before we went on break. So these were our rules for if we'll have 2 solutions, 1 solution, or no solutions. It's if the reference angle is greater than the given angle, there will be 2 solutions. If the reference angle is less than the given angle, there will be 1 solution. And if the reference angle does not exist, there will be 0 solutions. Or, which I thought was easier to remember, is that if the side opposite the given angle is greater than the side opposite of the required angle, there is only 1 solution to the problem. And if the side opposite the given angle is less than it, then there will be either 2 solutions or 1 solution. So that was like this very first example that's on page 197. If you look here, here's my given angle. Here's 4 centimeters from the side across from the given angle. And then we have 6 centimeters as the adjacent side to that angle. Now, if you look, this side's shorter than this one. And in this case, it came out with 2 solutions. Okay, so that's how I can tell. Whereas if we jump over to an example on page 200, when I had this case right here, this side was 4 centimeters. So right here, this is 4 centimeters. That's longer than this side, and this resulted in only 1 solution. Okay. Now the third situation that you have to be careful of is one that looks like this, where it's only 1 centimeter long here. This side doesn't actually reach across, so no triangle is made, and then there's no solution to this problem. Okay? So let's take a look, and we'll do an example here. So let me draw out question number 2. It says, calculate angle C in triangle ABC, where angle B is equal to 29 degrees, C is equal to 8.2 centimeters, and B is equal to 6.7 centimeters. Okay, so let's draw a quick little triangle here. I got B, C, A, 6.7, 8.2, and 29. Okay, here's my given angle. Here's the side across from it. How does it relate to this one? Shorter, so what does that tell me? That means that there is going to be either 2 solutions or no solution.
Why or no solution?
Because if this side's too short to reach across, then it doesn't make a triangle. So the only way you can tell now is to put it into our sine law. So let's do it really quickly here. So I'm going to have 20 sine of 29 degrees over 6.7 is equal to 8.2 on the bottom over sine of C, because this side relates to this side. So we cross multiply and divide. Sine 29 multiplied by 8.2, close the bracket, divided by 6.7. Second function sine, throw that in there, so you get 36 degrees. So that means I could draw one triangle that would be 36 degrees. And then how do I find its alternative triangle? Morgan.
Subtract from 180.
Yeah, so I just go 180 minus 36. And you get 144. Okay? Pretty easy. And then to find the other triangle, then I would just have to work from there. Are there any questions that you guys need me to go over? That was sine law. So Heather? 5B. I'd love to do 5B. I think that one was tricky because they wanted you to find the angle that's not part of the sine law. So you have to do it twice. So let's take a look. So it says, I have triangle EFG and angle GEF, so angle E, is 53 degrees. Side E to F is 7.2 and side GF is 6.5. Determine, so find angle F. Okay. So here's my triangle. I never draw my triangles to scale. For me, that's not what I'm worried about. I just throw them out there. So here's E, F, G. So that means this is little e, this is little g, and this is little f. And if this is angle 53 degrees, then E to F right here is 7.2, and G to F is 6.5. So right off the bat, do I have a side-side angle situation? Remember we said ambiguous case can only happen if I have side-side angle? So that's why I have, right? A side, and then angle floating on the outside. So now once I see that, I have to be careful. This might be ambiguous. So now, is the side that's across from the given angle shorter than the side that's adjacent? Yes. So this means I could have two solutions or no solutions. So let's take a look now. Let's go sine of 53 divided by 6.5 is equal to 7.2 over the sine of G. So I'm looking for G. But here's the problem. They want me to find F. So I'm going to have to build two triangles and then find F after. Okay, so G is not the angle I'm looking for, it's F. So let's go through. Let's go sine of 53, close the bracket, multiply that by 7.2, divide that by 6.5. Second function, sine. Put my answer in there. I get 62 degrees up here. Now, I don't think that's the answer for this one. For 5B, no, it says it's 9 degrees. So what I need to do is I need to get 62 plus 53 and take that away. So we're going to go 62 plus 53, subtract that from 180. Oh, whoops. And you get 65 degrees. So F for my first triangle would be first solution would be angle G is equal to 62 degrees and angle F is equal to 65 degrees. Now my second solution is going to be where I have to go 62 and take away 180, and that's going to equal 118 degrees. So now if I build out that triangle, so angle G is equal to 118 degrees, and then angle F is going to be 53 plus 118, take away 180, gives me 9 degrees. And that's how you get those two solutions. Is that okay? Perfect. I think that concludes all the homework that we need to take up for today.